MS Ramaya University of Applied Sciences.
Hi students, let us discuss in situ density by sand replacement method. The aim of the experiment is to determine the in situ density of soils by sand replacement method as per IS 2720 Part 28, 1974. In situ density is defined as the bulk density of soil measured at its actual depth. Density is used to calculate the stress in the soil due to its overburden pressure. By conducting this test, it is possible to determine the field density of the soil. The moisture content is likely to vary from time, and hence the field density also varies, and hence the test result in terms of dry density should also be calculated. The in situ density of natural soil is needed for the determination of bearing capacity of soils, settlement of footings, earth pressures behind the retaining walls, dams, embankments, stability analysis of slopes, controls the field compaction of soils, experimental setup, sand pouring apparatus, soil tray with a central hole, balance of 15 kg capacity, sensitive balance accurate to 0.1 grams, oven, calibrating container, tools for excavating holes. Experimental procedure. Calibration of the apparatus. Take required amount of sand and pour it into the apparatus with valve closed and fill it to the top with sand. Level and determine the weight of the apparatus and sand W1. Open the valve of the shutter and allow the sand to run out of the cylinder to the conical portion. Close the valve when no further sand runs out. Obtain the weight of the cylinder with remaining sand W2. The weight of sand required to fill the cone of the apparatus is given by W1 minus W2. Fill the sand pouring apparatus, that is cylinder, with known weight of sand W3. Place the cylinder centrally above the calibrating container. While placing, bottom of the conical portion should coincide with the top of the container. Allow the sand to run into the container as well as the conical portion until both are filled. Close the shutter when no further sand runs out. Weigh the cylinder with the remaining sand W4. Obtain the weight of the sand filling the calibrating cylinder as well as the cone W3 minus W4. Obtain the weight of the sand required to fill the calibrating cylinder as W3 minus W4 minus W1 minus W2. Calculate the volume of the calibrating cylinder either by measuring the dimensions or filling it with water. Determine the density of sand by using the mass filled in the calibrating cylinder and its volume. For field density, prepare the surface of the location so that it is a level plane. Keep the metal tray with hole firmly on the surface. Excavate a hole whose diameter is equal to the hole of the plate. The depth of the hole excavated should be equal to the depth of calibrating container. Collect all the soil which is excavated in a container without losing it and measure its weight W5. Fill the apparatus with sand and weigh it W6. Remove the tray and place the cylinder exactly above the hole. Open the valve and allow the sand to flow into the hole. Close the valve when sand stops flowing into the hole. Weigh the apparatus with remaining sand W7 and determine the weight of the sand occupying the hole. Calculate the volume of the hole V from the known weight of sand filling the hole and the known density of sand. Mix the excavated soil thoroughly and weigh a small amount for water content determination. Knowing the volume of the hole V and the weight of the soil scooped out from the hole W5, in situ density is calculated as gamma equal to W5 by V. The data collection and tabulation are shown in the tables. Calculations and computations. In situ density of the soil gamma equal to W5 by V, moisture content in percentage W equal to WW by WS, dry density gamma D equal to gamma by 1 plus W are calculated. The results of in situ density gamma and dry density gamma D are presented.
Dear students, today we will be performing the sand replacement method of finding out the in situ density of the soil sample. The apparatus required for this experiment are a weighing balance. Weighing balance is used to weigh the sand as well as the soil sample. A tray. The tray is used to measure the sand sample for calibrating the sand. Trowel. The trowel is used to loosen the soil sample in the field. Sand. This is the sand sample which is used to calibrate the soil sample. This sample should pass through 1 mm and should be retained in 600 micron sieve. A tray with a hole. The tray with the central hole is used to make the hole in the field and also to collect the soil sample when the hole is excavated in the field. A sand pouring cylinder which is used to fill the hole in the field with the sand, with a calibrated sand. Now it consists of a lever and a hole, a small hole inside. Now this hole can be opened and closed by operating this lever. This hole will help the sand to fall into the hole which is excavated in the field. This sand pouring cylinder also contains a conical portion in the bottom and a calibrating container whose internal diameter is 10 centimeter and a height of 15 centimeter. The volume of the container can be obtained from the dimensions or it can be obtained by filling this container with water. Measure around 4 kg of clean sand which passes through 1 mm and retained on 600 micron sieve. After measuring 4 kg of the sand sample, take the sand pouring cylinder. Now the hole inside is open. Use the valve to completely close it. Once it is completely closed, keep it on a firm ground and fill the sand sample into this sand pouring cylinder to a height below the top level of the sand pouring cylinder. Now pour the sand into the sand pouring cylinder. Level the top surface of the sand pouring cylinder. Clean the outer surface of the cylinder. Now weigh the sand pouring cylinder along with the sand. 5.395 kilogram is the weight of the sand pouring cylinder along with the sand in the cylinder. Now we have to weigh the empty weight of this calibrating container. The empty weight of the calibrating container is 2.247 kg. After weighing the calibrating container, keep it on the tray. Now place the sand pouring cylinder on the top of the calibrating container such that this hole is completely covered by the hole in the sand pouring cylinder. After placing it firmly, open the valve so that sand falls into the calibrating container. Once the movement of the sand stops, close the valve and weigh the sand pouring cylinder. Now, the difference between the initial weight and this weight gives the amount of sand which is required to fill the calibrating container as well as the conical portion on the bottom of the sand pouring cylinder. Now weigh the calibrating container with the sand. This weight includes the weight which is filling the container as well as the conical portion. Now, to find out the amount of sand which is filling only the calibrating container, we have to deduct the weight of the sand which is filling this conical portion. For that, we have to keep the sand pouring cylinder in the tray and open the valve again. Once the valve is opened, the sand will be moving down, filling the conical portion in this sand pouring cylinder. Once the movement stops, close the valve. Now weigh this sand pouring cylinder in the weighing machine. Now the difference between the previous weight and this weight is going to give you the weight of the sand sample which is required to fill the conical portion of this sand pouring cylinder. Now, knowing that weight, you can find out the weight of the soil sample which fills the calibrating container alone. After getting the weight of the sand sample which fills the calibrating container alone, we can, knowing the volume of that, we can find out the density of the sand which fills that calibrating container. That finishes the calibrating part of the sand replacement method. Once the calibration is over, we will fill the sand pouring cylinder with some more sand till a portion below the top and weigh it. The weight of the sand pouring cylinder now is 4.973 kilogram. Now we will take the tray with the hole to the field along with this sand pouring cylinder and a trowel, and we will continue it in the field. Upon reaching the field, first clean and level the surface. Then place the tray with the hole in its center on the leveled surface. After placing it, dig a hole in such a way that the diameter of the hole is equal to the diameter of the hole in the tray, and collect all the soil sample from the hole to the tray itself. The hole should be dug up to a depth of 15 centimeter, which is equal to the height of the calibrating container. Care should be taken not to lose any soil sample from the hole. After digging the hole up to a depth of about 15 centimeter, place the sand pouring cylinder on the top of the hole. Open the valve and allow the sand to fall into the hole. Once the movement stops, you can close the valve and weigh the sand pouring cylinder. Now the weight of the sand pouring cylinder after filling the hole and the conical portion is 3.735 kg. Now from this we can calculate the amount of sand which is required to fill that hole. Now the amount of soil which is collected from the hole should also be weighed. So for that we will just transfer that soil into this tray and measure it. Now the weight of the soil from the hole is 1.165 kg. Now that finishes the experiment.
At MSR UAS, we spark your imagination unlike any other.